direct ఉంటుంది 2 NaOH. Write it down. 2 NaNO3, 2 NaNO3 plus H2O. So in this case, N factor is equals to 2. NH4Cl. NH4Cl plus NaOH. Right? NaCl plus H2O plus ammonia. So N factor is equals to 2. So sorry. This 1 1. ఒకటే OH మైనస్ తీసుకున్నారు. రైట్ రా. ఈక్వలెంట్ వెయిట్ ఆఫ్ వాటర్ ఇక్కడ ఇది కూడా చాలా ఇంపార్టెంట్. ఈక్వలెంట్ వెయిట్ ఆఫ్ వాటర్. How can you calculate equivalent weight of hydrogen plus equivalent weight of oxygen? Write it down. Equivalent weight of water, manchika. Equivalent weight of hydrogen is 1 ra, oxygen is equivalent weight of oxygen. What Nana? You should also write because solutions. So next to that Raoult's law, those things I'll discuss. Okay now. Previous slide, okay. So just here is here onwards, just take it down. Right. Molarity I just explained, okay. Do you know molarity? So solutions. So just take this as molarity. I'll revise, just take the screenshot. You have 12 counts. Done? Do one thing right now, so no need. Okay, now onwards just write it down. The air onwards is important. Next, equivalent weight of oxygen is how much? Oxygen atomic weight is how much? No? 16. By its valency 8. Oxygen ki -2 2. No, atom what I'm speaking. EHCl, equivalent weight of HCl, EH plus ECl, right? 1 plus 35.5, 36.5. Write it down. NaCl, ENA plus ECl. ENA is how much? 20. Streaming అవుతుందా? ENA sodium 23. Cl 35.5, 58.5, right? E Na to SO4. ENA plus ESO4. 2 minus. This is 23 plus 48. How much? 71. So what is the use of this, all this? Hello. So what is the use? Why I am telling all this? Write a question. Equivalent weight of metal oxide is, this type of questions they are frequently asking. Equivalent. Huh? Now is it okay? And did you copy? Yes, sir. Yeah. Write a question. Equivalent weight of metal oxide. Equivalent weight of metal oxide is 20. Calculate equivalent weight of metal. Calculate equivalent weight of metal and its chloride. Like this, they'll ask a question. Ante then mx, so manaki metal oxide EMO M2OX. Yes, because metal oxide, oxygen is 2, metal we don't know, X. So equivalent weight of metal we need to find. We don't know the equivalent weight of. So from this, whatever which I taught, from that we can do. What is that? How can we do it? Equivalent weight of M2OX is equals to equivalent weight of metal plus equivalent weight of oxygen. So equivalent weight of metal oxide is given. How much? 20. Equivalent weight of metal plus equivalent weight of oxygen is 8. So equivalent weight of metal is how much? Hello? 12. So once we know equivalent weight of chloride, they are asking metal chloride, it's chloride. So equivalent weight of metal plus equivalent weight of chloride, 12 plus 35.5. Anything, if they are asking anything, so we have to solve like this. So this type of questions frequently they are asking, but a lot of people are confusing and they don't know how to solve this type of question. Okay, na? Vanshika. Calculate normality. Calculate normality 36.6 grams of 31.6 grams of KMnO4, 36.6 grams of KMnO4 in 500 ml solution, in 500 ml acidic solution, acidic solution. So Kmin for molecular weight is how much, Nana? 158. 158. So what we need to do? We need to calculate the normality. We need to calculate the normality. Normality is equals to what now? Weight by, so molecular weight by n factor into 1000 upon V in ml. So weight is given 31.6 by molecular weight 158. 158 by n factor is how much? Kmin for n factor, Nana. In acidic medium, in acidic medium, n is equals to 5. Vanshika, write this one, band. So basic medium 1, acidic medium 5, neutral medium 3. Right, so it is 5 into 1000 upon 500. Right? How much you got? Whatever it may be. Got it? So how we can calculate the normality? Redox reactions. Then mix chestuna kavalani. But ఎందుకంటే lot of things people are confusing here and there. Actually normality కొంచెం definition ఇచ్చేసి వదిలిపెడతాం solutions. But when it comes to the n factor and all those cases which I am giving the information comes on the redox reaction. So ఇక్కడ ఇంకొంచెం calculating the n factor for the following reactants and products, something different. Write it down. H2S. Yes. What is the n factor for this? And what is the n factor for this? What is the n factor now? It is 0, it is -2, right? What is the difference? 2. So here is also we need to cross check. What is the difference? 2. Okay, write it down. 2 to n factor. So this is important. Next one. FeO Fe2O3. What is the n factor here and what is the n factor here? By default, here is +2, +3. In this case, n factor is equals to 1. The difference is 1. In this case, n factor is equals to the difference is 1. But how many irons are here? 2. So this a lot of people are confusing in this place. Statement same number of replaceable number of electrons are transferred, but number of electrons are transferred here. Total we need to take 1 mole, right? And now how many irons are there? 2. So 1 into 2, 2. So like I told you, like Cr2O3, Cr2O7 2 minus gives rise to Cr3 plus. So in this case, what is the n factor? N factor is equal to 6. Here is what is n factor? 3. Because difference is 3, but 2 CRs, right? 2 into 3, 6. But only 1 CR here. For example, if even though if you are taking the 2 CRs, but we will take 3 only. Why? Because we are taking for 1 mole. This is 2 moles. This is 1 mole only. PbO, PbO2. Next. PbO, PbO2. Tell me the n factor. It is plus 2, plus 4. By default, 2, 2. టాపిక్ ఇంకొంచెం అవి మళ్ళీ ఆక్సిడేషన్ స్టేట్స్ అవన్నీ డిఫరెంట్గా ఉన్నాయి. ఇప్పుడు నేను ఐ గో విత్ దిస్ వన్, తర్వాత నేర్చుకున్నాను. రైట్. సో రైట్ నౌ వి డిస్కస్ నార్మాలిటీ, రైట్? So normality like this. N factor for acids, bases and salts, we are discussing this. So KMnO4. So the balancing equations, how do you know? Do you know? Right. So MnO4 minus gives rise to Mn2 plus. In acidic medium, how we have to balance? So for the balancing, first we need to accept hydrogen and oxygen. We need to balance. Here is oxygen is there, but only manganese. So already only 1 1. So no need to balance. Already balanced. Then we need to balance oxygens. Right? While balancing the oxygens in acidic medium, which side is oxygens are less? Right? That side what we need to do? ఏం చేయాలా? 4H2O exactly double 8H plus. Right? Which side is less number of oxygens? We need to add water. Then exactly double H plus ions we need to add opposite direction. Then we need to charge, balance the hydrogens. Of course, hydrogens are balanced. The next balance the charge. So 8H plus this total plus 7 charge is here. 8 plus 1 minus 7. In this case plus 2. So 5 electrons are when we need to add this side or this side? This side. 5 electrons. This is the balancing. Okay, Vanshika, clear?
Yes, sir.
So what we need to do, how to balance, let me know. First, except hydrogen and oxygen, we need to balance.
Yes.
First manganese.
After that, hydrogen was not there, so we balanced using H2O for oxygen, and there 8H plus. So over there plus 7 and there plus 2 for manganese. So that's why we added 5.
Because here is plus 7 means 5, 7 electrons are less. So, lot of people are thinking that array this is a big number, that is small number, right? Not like that. Okay. Chalo. So this is the equation which we need to do. N factor is 5. Examples already I discussed. Next, write this formula. ppm, parts per million. Parts per million. So same like weight of solute by weight of solution into 10 to the power of 6. Means if you are taking the 100% per million, 10 to the power of 6. Why we will take this ppm? Why we have to study? Because see, when the solute is very trace quantities, that cases we will use this. Means for example, the chlorine percentage in water, for example 0.000003%, for example, if I am taking in percent in 3 ppm, so which is seems to be good? 3 ppm. That's the reason we will use this one. Where is your nose? Means what we would say like this. Can't we say like this, right? So the like that. So that's the reason we'll use 10 to the power of 6. Yeah, write it down. Parts per million. Vanshika completed a nomenclature part? Vanshika? Yeah. Did you revise any other notebooks or something?
Sir, actually I knew the basics, but I just need for the styling inside atom.
Okay.
For that, I just had doubt. For it, I did it, but I was having few doubts.
Okay, no issues. We'll do that. So mole fraction. So mole fraction means what? Number of moles of solute by total number of moles, right? So simply number of moles, mole fraction. For example, in a solution, imagine A and B two components are present. A is having the number of moles is Na, B is having the number of moles Nb. So mole fraction of A is equals to, how can we write? Na by number of moles of A by Na plus Nb. Xb is equals to same, Nb by Na plus Nb. Xa plus Xb is equals to 1. So this is also important while we are calculating the relative lowering of vapor pressure. Relative lowering of vapor pressure will use to equals to mole fraction. Write it down this. Mole fraction. Mole fraction also independent of temperature because there is no volume term. There is no volume term. Right? So unsaturated, saturated and supersaturated solutions. Unsaturated means what? It is a solution which more amount of, right, can be dissolved in a particular temperature. Saturated means the solution in which no more solute can be dissolved at the particular temperature. Supersaturated means solution which contains more amount of the dissolved solute than the saturated solutions. For example, my capacity to eat apples is 2. If I eat 1 apple, unsaturated. If I eat 2, saturated. If I eat 3, supersaturated. Simple. Saturated, unsaturated, saturated, supersaturated. Right? Supersaturated solutions, it should be prepared from dust-free vessels and this is not needed. Next, solubility of gas in a liquid. So it's very important. Solubility of gas in a liquid, solubility of one of the substance, nature of the solvent and gas, temperature and pressure. So if I am speaking about the temperature, if I am increasing the temperature, solubility of gas in the liquid, what happens? Decreases, right? When we are boiling in the water, air bubbles are coming, right? Nothing but the dissolved gas is coming out. That's the reason in the aquatic like lakes and their fishes wants to stay in the down, not in the surface. And if you are increasing the pressure, what happens? The solubility of gas in the liquid increases, right? That's the reason cool drinks. That is nothing but Henry's law. What is Henry's law? P is directly proportional to X. P is equals to KH into X. KH into X. And KH is nothing but Henry's law constant. What is the P? The pressure which we are partial pressure which we are applying the gas, the amount of solute of the gas, the mole fraction of gas is more. Means P is directly proportional to X means what? If you are passing the more pressure, more amount of gas is soluble in the liquid. What is X? Mole fraction, right? P is equals to KH into N2 by N1 plus N2. From that they are asking the numericals here.
KH constant.
So KH is constant, but KH is for example same gas. KH is constant. For the different temperatures for the same gas, KH value is different. For example, oxygen KH value is different at particular temperature. If you are increasing the temperature, KH value is also increases. So based on this also KH value also they ask the question. If KH value is increases, what about the solubility of gas in the liquid? Because KH is directly proportional to temperature. If the KH value, if the temperature increases, KH value is also increases. Based on this point, they ask the question. I'll show you that. Solubility of a substance in a maximum amount of that can be dissolved in a specific amount of solvent. Generally, 100 grams of solvent is a specified temperature from a saturated solution. So nature of solvent, like dissolves like means what? Polar compounds are soluble in polar solvents and non-polar compounds are non-soluble in non-polar solvents. What is polarity? Polar and non-polar? For example, water is there. What is polar or non-polar?
Polar.
Polar. Electronegativity difference is there, right? Polar gases are dissolved in polar solvents and non-polar gases are dissolved in non-polar solvents. When a gas undergoes ionization, right, it's highly soluble, right? HCl is highly soluble in water. So this is the nature of solvent and gas. Nature, like dissolves, like even solids and liquids also it's applicable. Done? I told you effect of temperature. Generally, dissolution of gas in the liquid is exothermic reaction. Some cases. Exothermic means what? So temperature increases, solubility decreases. Oxygen dissolves only in a small extent in water. So it is dissolved in oxygen, sustainable for the aquatic life. Which one? Easy, kada? See, for example, it is exothermic reaction. Na is not here. In case of solids, we'll discuss. For example, solubility of solid in the liquid. Solid in liquid. Okay. If it is the dissolution process is exothermic. Exothermic. Exothermic means what? For example, take cool water, add some solute, heat is generated. Heat is liberated and the glass will become hard. Right? So, exothermic means it is giving the heat. Means what we need to maintain? We need to maintain low temperatures. Right? Exothermic reactions, low temperatures are favorable. Then more soluble. If it is endothermic, high temperatures are favorable. Simple. Solubility of gases increase with the decreasing of temperature due to aquatic species are more comfortable in cold waters rather than the warm water. So generally aquatic life, fishes and all, are more comfortable in the cold water. Effect of pressure, I already told you, X is directly proportional to P, or of course P is equals to KH into X. P is the partial pressure of the gas, KH is Henry's law constant, X is mole fraction. The solubility of a gas in a liquid at a given temperature is directly proportional to partial pressure which is dissolved. Simple, if Henry's law case is cool drinks. Cool drinks. When we are opening the cool drink, what happens? Sound, because high amount of pressure is present. For example, cool drink is there, we just opened the and we kept for half an hour. So then afterwards, if we'll drink, how we will feel? Normal sugary drink, like normal sugar drink like that, right? So that is effect of pressure, Henry's law. So increases in the pressure, what exactly happens? More amount of gas is soluble. So that is a simple thing. And applications of Henry's law, I told you, in cool drinks, of course, and scuba diving. In scuba diving, what exactly happens? Vanshika, నీకు తెలుగు వస్తుందా? Vanshika, do you know Telugu?
No, sir.
Okay, you told I can understand.
Sir, a bit, but not during the
No issues, no issues. Yeah. So in scuba diving, what exactly happens? So for example, this is a oxygen cylinder. When we are going down in the sea, what exactly happens, Nana? Pressure is increases. So when pressure is increases, what exactly happens? High amount of gas which is dissolving in the liquid. High amount of gas which is dissolving in the liquid. So then, for example, he saw some snake or something, if right, he threatened something. So immediately, if he is coming up, immediately by fast, what happens? Right, when we open the cool drink bottle, so how the gas is coming out? So the dissolved oxygen, the dissolved gases is coming out from the body, because immediately there are a lot of pressure differences, right? Right. So to avoid that one, that we are called as what? Bends. That painful effects we are called as bends. To avoid that bends, what we need to do? So we need to come by stepwise process, not immediately. Anything, if any change, if you want, so we need to do in a slow mode, not extremely one day it won't happen like that. So they have to come stepwise process. First thing. And second thing, in the gas cylinder, instead of, because nitrogen is percentage how much, because of the painful effects, because of more amount of nitrogen, because oxygen doesn't matter. Nitrogen. So nitrogen is approximately 78%, right? So here is helium gas we are using, up to 11%. Nitrogen is replaced by the helium, right? Because the helium is noble gas and it is less dissolved when we compare with the nitrogen. And when it is coming out, less painful effects are there. So that's the reason in oxygen cylinders, 11% of right helium we will use. And if you are going to the next 4 applications, high yield stations. So if you are going top, what happens? Pressure is decreases, right? Here is low pressure, less amount of oxygen is dissolving in the blood. In the high yield stations, the people will feel, so if you are in the ground state, so the people are active. If they are going to the high yield stations, so dizzy, right? They won't think normal like people, normal people. So that state we are called as anoxia. Anoxia. These two are the application for the right Henry's law. Of course, I'll discuss here. Characteristics of Henry's law and Henry's law constant. I told you same unit that of the pressures. For example, tar or bar. Different gases have different KH values for the same solvent. KH value for different, right? For different solvents, KH value increases with increasing the temperature. This point is important, D point. Higher value of KH of gas, lower will be the solubility. So write this point. This point, this is important. I already told you. Of course, KH value different for different gases. Different temperatures also different. If the temperature increases, KH values also increases.
Basically, constant.
And it's not constant for all gases. Its value is different. For oxygen is different. Nitrogen. I'll give the table.
Yes.
Of course, in the NCRT also the table is given. You can go through the NCRT also. Right. Right. Mole fraction, partial pressures T1, T2, T3. So T1 is greater than T2, T3, KH1, KH2, KH3. So mole fraction, partial pressure, slope is KH like this. Done? Henry's law applicable to each gas independent of the pressure of the gases when we're comparing with, because Dalton's law of partial pressures like that, of course. Applications of Henry's law: increases the solubility of CO2 in the soft drinks, soda water bottles sealed in the high pressure that I already discussed. At high altitudes, partial pressure is oxygen is less than the ground level, that's called as anoxia. The scuba diving tanks are diluted with helium. So low blood oxygen levels causes anoxia. Here is ANO. The scuba diving, high concentration dissolves in the right when breathing and high pressures. What happens? Increases the pressure. I already discussed, right?
Yes.
So bubbles blocks that capillary tubes because of leakages that we are called as bends. To avoid the bends, toxic effects, concentration of nitrogen in the blood used by the scuba diving filled with diluted helium.
Bubbles are
Size తక్కువ ఉంటుంది, less dissolve. For example, if you are injecting with one syringe, imagine if the syringe is small size, if it is bigger size, what happens? So limitations, no? Henry's law is right, valid under the following conditions: pressure of the gas not too high and temperature is not too low. Gases should not undergo any chemical reactions with the solvent. The gases should not undergo dissociation or association in the solid. So this is important, this type. Which of the following is statement is correct? Which of the following? Sometimes they are asking. So write it down, Anna. Pressure of the gas is not too high. Temperature is not too low. Sometimes they are asking. Otherwise, you can go through the NCRT also, of course.
main.
Really? Oh. NCRT లో ఉన్న ప్రతిదీ ఉంటుంది ఆల్మోస్ట్. Vanshika, if possible, take screenshot, okay? That so vapor pressure, Nana. What exactly the vapor pressure? Here onwards, the Raoult's law and all vapor pressure is starting. For example, imagine take a vessel, take pure solvent. So when we are heating it, right? What exactly happens? It will be evaporates, right?
Okay.
If we are closing this with a container, what exactly happens? These gas particles after, right, is coming out. After some time, equilibrium is established between these gas molecules and the liquid. Okay, so here the pressure exerted, the pressure after at the equilibrium now, after attaining the equilibrium, the pressure exerted on the surface of liquid because of these vapors, gas molecules, that we are called as vapor pressure. So equilibrium should be present. What is equilibrium? The gas, for example, 10 gases are coming inside, the same time 10 gases going in the vapor phase. Okay, the pressure exerted on the surface of liquid we are called as vapor pressure. If I am taking the pure solvent, for example P naught, okay, sometimes solute also, it is solute also volatile, that also we can take, right? It's not solution, it's not solution, only solvent. Imagine pure water, pure water. Okay, first what is vapor pressure we need to know. Right, at equilibrium I said, right, the set of rapidly in which the number of particles are leaving the surface exactly balanced by the rejoining. So means at equilibrium, how many are going gases, the gases is coming in as a liquid. So at equilibrium, rate of evaporation is equals to rate of condensation. H2O liquid is equals to H2O gas. Kp is equals to P equilibrium. Kp is equals to vapor pressure. K is P. So rate is equals to time, right? Rate of evaporation, rate of condensation is equal. Where at pressure, right? At equilibrium what happens? Rate of vaporization and rate of condensation is equal. I already told you, right? Clear, Vanshika? Any doubt?
A graph me.
So both are equal. Rate of at equilibrium. What I'm speaking? At equilibrium. Nothing. It's equilibrium. They are in the equilibrium. Right, vapor pressure. The pressure exerted by the vapors of a solvent A and solute B in the equilibrium phase. The vapor pressure of a liquid does not depend on which one? All, right? The amount of liquid taken, surface area of the liquid, volume of shape of the container. It independent of nature of the liquid, intermolecular attractions, vapor pressure is increases, boiling point decreases. Loosely held molecules escapes more easily in the vapor phase. Got it? For example, I'll discuss that is in Raoult's law case. So boiling point means what? Temperature at which vapor pressure of the liquid is equals to atmospheric vapor pressure. Normally Boiling point means generally we'll give one statement when liquid converting into vapor, right? But here we will speak in terms of vapor pressure. Hello. Now onwards we'll speak in terms of vapor pressure. Even in colligative properties also we'll speak in terms of vapor pressure. What exactly the boiling point here means? For example, here is the liquid. Is having the gas is having, for example, 1 atm pressure. So the liquid is also, this vapor pressure is also equals to 1 atm pressure. That cases we'll say the boiling point. So vapor pressure of liquid and vapor pressure of gas should be equal. That's nothing but boiling point. So relative humidity, so means partial pressure of water vapors at given temperature by vapor pressure at H2 as same temperature into 100. Okay, relative humidity. So humidity means what? If any water molecules are present. Okay. Right, Nana. Temperature. More molecules from the liquid, enough kinetic energy to escape the molecule. So if temperature increases, kinetic energy of the particles also increases. Automatically vapor pressure also increases. When the temperature increases, automatically vapor pressure also increases. Write this one. Just write. The temperature increases, kinetic energy of the molecule particles are increases. Then according to Le Chatelier principle, how many of you know Le Chatelier principle? So that's one I told you, right? For example, reactants converting into products are converting. For example, forward reaction is imagine exothermic. Forward reaction is exothermic, means backward reaction is what? Endothermic. For example, if I am increasing the temperature, which reaction takes place? Backward reaction. Backward, because forward reaction is exothermic. Exothermic means what? Heat is releasing. Low temperatures are favorable. So always remember, exothermic reactions are favorable. What, Nana? Low temperature. Endothermic favorable, high temperatures. Okay? Vanshika, clear? So this is Clausius-Capron equation. So based on which one? Right? Depend on vapor pressure and temperature. Right? Vapor pressure and temperature is given by Clausius-Capron equation. So P2 by P1 delta HV 1 by T2 minus 1 by T1. P2 by P1. Just go through the NCERT, of course, after this. Advanced use aitadi. So phase diagram is also not needed. So Raoult's Nana. Raoult's law I'll explain about. Raoult's law, in Raoult's law, same P is directly proportional to X. Okay. In Henry's law and Raoult's law, what is the main difference? In case of Henry's law, the solute is only gas. But in this case, we'll take liquid or solids, anything we can take in the Raoult's law. And I told you vapor pressure. For example, I'm just taking the solvent, right? What? Solvent, pure water, imagine water. After dynamic equilibrium, what exactly happens? Right, PA. I'm just taking solvent is A. So P naught A. P naught, the vapor pressure is in case of, I'm saying that P naught A. What is P naught A? Vapor pressure of pure solvent. Just write it down, very important. P naught A means what is? Vapor pressure of pure solvent. Imagine I'm just taking the solute. Solute also, imagine volatile solute. Solute. This is B anukun. This is A, solvent A, solute B. Vapor pressure is coming over here, right? Even for this. This is what? P naught B. What is P naught B? Vapor pressure of pure solute. Vapor pressure of pure solute. Container should be closed, because if the container is open, it becomes. Raoult's law will discuss in two cases now. Case 1, case 2. Case 1, volatile solute. Case 2, non-volatile solute. Non-volatile solute. Case 1 is volatile solute, case 2 non-volatile solute. Okay. So first we'll go with the case 1, volatile solute. Case 1.